All right, guys. So, what I want to do with you guys today is just a little bit more practice using substitution, but a little bit more complicated systems, okay? That we're going to break down the systems so they are nice and easy, just like we did yesterday. Because you guys agree yesterday wasn't horrible? Pretty nice? Okay. So before we do that, I want to sprinkle word problems all throughout the unit, and then we spend a full day at the very end doing just word problems so we get used to all the different types. Um, so for this example one, have we actually did this type already? Mm-hmm. Yeah, this one, is it exactly like the last one I just did with you? Mm-hmm. Just because it's a different scenario, it's the same type. Like the last one was movie tickets, right? A number of children and adults. This one's a dance recital. So you guys will see that a lot of the word problems are very similar on how we set them up. Okay. So here it just says at a dance recital, there's 220 people. Tickets cost $9 for adults and $6 for a child. The dance school collected $1,614 in ticket sales. How many adults and how many children attended the recital? So again, we're setting this up from scratch. So we have to write equations. First thing is, and again, guys, I'm telling you the steps right now because we're learning this and my expectations of you. But on a quiz or a test, it's just going to have the question and a blank space, right? So I need you to know that even though I might not ask you to do it, do you need to set up your variables? Yes, right? If you don't have your definition of your variables, you lose marks on that because technically we don't know what your variables represent unless you tell me. So what do you guys want to use for number of adult tickets? What variable you pick? Sure. And again, you guys can use whatever you want. So let's use A for number of adult tickets. That's what I'm going to do. And we talked about this last class. Writing adults right beside the A is not good enough. Okay. It has to be more specific. What about the adults? Because again, it could maybe be the cost of a ticket, an adult ticket, even though it's already in the question. You have to be a little bit more specific than just adult beside A. And then what do you guys want for child? Any guesses? Guess what I'm going to use? C. All right. So we haven't wrote the system yet. So this is, like I said, very similar to the last one. We have a money situation, right? So all the money stuff goes in one equation. And then we have a total equation. Okay. So away we go. So we're going to have A plus C equals what? 220. And then our money equation is going to be 9 what? A plus 6C will equal our total money, which is 1640. So there's our lovely system. Okay. So now, since we're practicing substitution, we'll use substitution to solve it. But technically, guys, could you solve this on your calculator? Yeah. If it says algebraically, then you either have to use substitution or elimination, which you're going to learn on Monday. Okay. But right now, you don't know elimination. So we're going to solve everything algebraically today. So you will have to use substitution. Right? Because we are going to practice algebra today. All right. So does it make sense which equation we're going to use the substitution on? Yeah, the top one. Because if you use the bottom one, then you're going to end up with fractions, which again, you could totally do. It works. There's just more room for error. So I'm going to use the top equation, and I'm going to solve for A. If you guys want to solve for C, go ahead. We're going to get the same answer. Right? So if I take the top equation and solve for A, I'm going to get 220 minus C. And then you guys know that we're going to take what we just substituted, or moved around, sorry, and we're going to substitute it in the other equation. And we're going to situate it right beside what number? What number we're going to put it beside? We're going to put it beside the... What number are we going to put the substitution in? Goodness, guys. Right? So again, our substitution is going in for A, so that means it's going in right beside the 9. Okay? So that's where the substitution's headed. Because we know that A equals 220 minus C, so wherever the A is in the other equation, that's where the substitution goes. So now it's going to be 9 times the A, which is 220 minus C, and everything else stays exactly the same. So I have a plus 6C equals 1614. So then you guys know to get rid of the brackets, we multiply the 9 in. So we have 1980 minus 9C plus 6C. So if we just take the constant over, we're going to be left with a minus 3C on the left-hand side, which will work out because are we going to end up with a negative number on the other side? Yeah, so because again, if you guys solve this system and you get a negative answer for C, do you know that you did something wrong? Yeah, because you can't have negative number of children attending something.
Yes, you can.
Yeah. Well, that's all good. I knew you were here. So I guess the only way that is maybe if the children didn't show up, but you still sold the tickets, right? So it's still technically a positive. All right, so we have negative 366. So if you divide both sides by C, by negative 3, perfect, you'll get 122. Exactly. So we have 122 as our C value. So it looks like 122 children attended. And then just like we did last class, you take and solve for the other variable. And this is definitely one nice thing about substitution, guys. Solving for the other variable will be quick because do you always have at least one equation already rearranged for the other variable? Yes. So that's the beauty about this method. So then all you have to do is go your 220 minus your 122. Yes. Right. And then when it says interpret the solution, that's just your sentence describing what you actually solved for, right? So this is just saying, right, there were 122 children and 98 adults that attended the dance recital. So again, anytime I ask you to explain the solution, both numbers that are in your solution should be part of your sentence. Okay? You can't just say that the solution represents how many went. Okay? More specific, the two numbers that are in your solution have to be part of your sentence. All right. So, again, it's just nice to start with a little word problem because I promise you guys, word problems in this unit are not scary. Okay, you'll get enough practice with all the different types that you should be able to look at every single type once we're finished and be very confident and secure in setting up the system. Okay. All right. So with this example here, again, we're just solving by substitution. Does this look a tiny bit different in one sense than the ones we did yesterday? Yeah. All the ones we did yesterday all had what kind of coefficients and constants? They all were integers. Do you guys agree? So here, don't freak out, right? If I throw some decimals in there, do we still follow the same process? Yes. Because in this system, do we still have a variable by itself? Yeah. So to me, are decimals okay to work with? Terminating decimals aren't horrible, so we just deal with the decimals, okay? Could you change them back to fractions if you wanted to? Yeah, you could, but that's more work. You guys can deal with decimals. So do this question exactly the same way as you did all the ones yesterday and the one like we did today. It's just you'll probably use your calculator more, right? Yesterday, we could do so much more of the math in our head, right? Because we're just timesing 4 by 3s and 6s by -4s, right? Where I don't expect you guys to take decimals and add, subtract, multiply, divide them in your head unless you want to, but I'm not going to, okay? Right? It's just more complicated. So we can use our calculator to speed up the process. So the top one definitely has a variable by itself. So that's the one I would use to rearrange. So I'm going to get y equals 6 minus 0.4x. We all agree? So then that is my equation now. So this gets substituted into my other equation where the y is. So that's going to be right beside the 5. So we take one equation, we rearrange it for a variable, and then we substitute it into the other equation for that variable. All right, so let's see what we got here. So we have 1.2, whoopsie, 1.2x minus 5. Remember, it's 5 times y, so we just figured out that y was 6 minus 0.4x, and that still equals 18. So go ahead and solve that. So get rid of the brackets, multiply it in. Did you guys get 15 for x? Good, good, good. Keep going. Yep. Because remember, when you're done, guys, should you always have 2 answers if you're dealing with this system of equations and 2 variables? Yeah. So the only way you wouldn't get 2 answers is if on a test or a quiz, I just said the value of y is, right? So if I only asked for one, then I guess you could stop. But if I asked you for the full solution, you should always have both. And did you guys get 0 for y? Good. Perfect, perfect. And again, the nice thing is, could you put them back in? Not writing it down, but could you put x back in beside the 0.4, the y back in for the y, and should it equal 6? Yeah, so again, you could check it back into your originals. Okay. I'll let that be up to you, but you should definitely be doing that on quizzes and tests, right? Double checking to make sure you've done the math right. All right, so is B very similar to what we just did? Yeah, bigger decimals, but same thing. So I'm just going to leave that one for right now. I'll leave you guys to do that. I'll still do it with you. And then something like this, they could get worse in the sense of, is the top one nice? Yes. The bottom one has a fraction in it, but is that fraction actually horrible? No. But I want to remind you guys, if you didn't like the fractions, could you get rid of it? Yes, you could multiply that whole bottom equation by what? You guys remember general form? It's the same idea. You can multiply that whole bottom equation by 4. So you will get into some systems where probably getting rid of the fractions would make more sense to clean it up. In this situation, do we really need to? No. If you want to, go ahead, but I'm not going to. But there will be questions where it makes more sense to get rid of the fractions before you start the question than leaving it. So just be prepared for that. So those are the only two left. I guess we'll do them in order. It doesn't matter. So I'm going to have you do both of them anyway. I'm just going to do them quietly now. So when you're finished both of these, look up to make sure, even though you'll know if you've done them right because you're going to check them yourself. But when you're finished, go back, make sure your yesterday's homework's done, and then you can do the assignment that connects to this lesson as well. Why is these? Actually, let's talk about that, guys. Could you technically, if you wanted to, get rid of all the decimals for this one? Yeah. You could. You times it by 100, right? So technically, and the thing is, the top one, if you left that one, technically, could you get rid of the decimals in the second one instead? If you didn't want to deal with the decimals, you could. Right? So if you don't like them, don't complain about them, get rid of them. It's just lots of, yeah. Exactly. Decimals and fractions, guys, you just end up using your calculator more. It's no big deal. But again, realize you guys have the skills. If you don't like something, decimals or fractions, you can always get rid of them. Not on your IB test. Well, not if you're taking IB. If you're taking IB math and you choose not to do the IB, then I guess, but then you're not taking IB math.
I just stress myself. There's difference.
Yep. So yeah, when you're done those two guys, move on to the assignment. Get her done. Then you'll have no homework for your guys' lovely long weekend. Lucky duckies. No school tomorrow. And remember, guys, if you're dealing with the decimals, do you have to write the entire decimal down? Yeah, you can't round anything, right? So even though it's a 0.312, you have to use the full thing if you're leaving in decimal form. Because if you round, is it exact anymore? No, and you will not get the exact right answer. So if you're using decimals, you have to use the whole decimal or change it back to a fraction. Your calculator will do all that for you, right? If you choose to go back to fractions, if you want to. To me, they're not horrible decimals, so I'm going to leave it.
Just put negative 0.5. Use that to take these off. Check. What is wrong? Okay, my answer checks out. Do you have to check both equations?
Yeah, always.
I just didn't know if it mattered or not.
Yeah, because a lot of times, do you remember that first one we checked yesterday? It worked in the first, but it didn't work in the second.
I
No.
remember yesterday.
So yes, it is important that when you're checking, you check both.
I barely remember what time I woke up this morning. What is wrong with you?
So guys, does 2,000 and negative 50 look right for B? Okay. I haven't checked it, so I could have answered my own question, but I thought I would go to the experts. Does that somebody else get the same thing as me? Okay, good. Then I'm not going to check it
We're the experts.
right now because there's only one of me and there's like 32. Some people are missing, so 30 of you.
Yes. And we just not find out why I hated question B. It's not that it's hard. It just makes you question everything. You're like, there's no way y is equal to 2,000. It's immoral. Do we have to write down how we check our equations or just check them?
The only time I have to see your verification is if in the instructions I'll say solve and please verify. Then I need to see it written down.
And I hate it.
It's just tedious for sure.
It's less than 5, right? Why is my dog sleeping? My dog's great. Okay.
You're gonna steal him on Saturday.
No, you're not.
You can't. I saw dog-sized coats, like your dog-sized coats.
Yep.
I can't believe the image just called this dog sleeping.
Aww.
I'm gonna steal it when I come over on Saturday.
So,
He's not going to go on.
how big is he?
He's not very big.
Like, is he like this big? How big is he? Is he like?
8 pounds.
My
Aww.
dog is
And
6
like,
pounds, not to brag.
he's like
He
football
reminds
size.
me of
What's that? Here's a picture of his head.
your girlfriend.
That's my favorite photo. It's just him.
Oh.
This was last winter.
Hanging in front of the thing. That's awesome.
Like he's like a little,
Calm down.
he's on like a little couch with like circle background and stuff. It's really cute, bro.
Calm down. Listen, Imogen dogs are smaller. They're like 6 pounds each.
Well, one of them, my
Oh, really
one of them
tiny.
is smaller. He's 7 pounds, and the other one's 5 pounds. I'm like, trying to 7 pounds smaller because he's not. Anyway, I don't know body juice. My dog is not that strong. My dog's still cute. It's not that strong. What? My dog's like, when she's wet, she looks like a not weird. She looks
I have 2 white. Just kind of shake this, plug it in here.
Yeah.
Okay.
But, you know, graphically using technology. Whoa. What?
So guys, are we good with negative half for x and 6 for y? Is that what you guys got? So if you didn't, now double check both of these. I'll just double check too. So negative 4 plus 6. So Yep, they're good. So if you didn't get those, double check them, guys.
If I would use fractions,